Okay, so this is going to be the proof of the power rule. Remember that the power rule for a derivative is multiply by the power, subtract 1 from the exponent. This works for polynomials. It works great. It works for a lot of other things. You can do this term by term. So anything separated by n's. So oops, the derivative of 2x cubed plus 3x plus let's do a square root. Let's just do a square root. Let's do that. So we take the derivative. 3 times 2 is 6. X, reduce the power by 1. The power on the x is 1. 1 times 3 is 3. X to the 0. X to the 0 is just 1, so it goes away. This one, like to switch into a fractional power. So bring the 1/2 to the front, to the -1. Subtract 1 to the -1/2. And then the chain rule says multiply by the derivative of the inside. The derivative of 2x is 2. So now we simplify a little bit. The 2 and the 1/2 cancel. -1/2 moves it to the bottom, so it's 1/2 power in the denominator, which is a square root. So I'm about to prove this rule. So limit as h approaches 0, remember the definition of a derivative. Oops, over h. So this particular case is going to be x to the n. So x to the n, x plus h to the n minus x to the n. Now, there is a rule about factoring this that says so here's the factoring. A to the n minus b to the n equals a minus b, a to the n minus 1 plus a to the n minus 2. So that one, first one had a b to the 0. This one's a b to the 1 plus a to the n minus 3, b to the second plus a to the first, b to the n minus 2, and finally a to the 0, b to the n minus 1. Okay. You've seen this before somewhere in algebra 2 with a minus b with a difference of cubes, a squared plus a to the first, b to the first plus a to the 0, b to the second. So in this case, we get x plus h minus x. So a here is this guy, and b is that. So this is probably a new factoring rule. It hasn't been particularly practical until now. Not b to the 0. This is b to the 1. Or not b. Oh, I should probably do this not in terms of a's anymore. I should do this in terms of a is x plus h and b is x. And so on and so forth. Minus 2. Last one is x to the n minus 1. All over h. So in here, this little term here, x plus h minus x is just an h, which is now factored out, which means I can cancel it with that h, leaving me with this. I'm going to come over here so I have a little bit more space. Limit as h approaches 0 of and I got this nice long series here. So as h goes to 0, all of these x plus h's just become x's. So we're going to apply 0 to h. I don't need the limit anymore. Plugging in 0 for every h. So now I've got x to the n minus 1 plus x to the n minus 2x plus x to the n minus 3x squared plus x times x to the n minus 2 plus x to the n minus 1. So I've got an x to the n minus 1. X to the n minus 2 is n minus 2 plus 1 is n minus 1. N minus 3 plus 2 using my exponent rules. When I multiply, I add the exponents. All of these terms are x to the n minus 1s. And there's a total of n of them. So that means n times x to the n minus 1. And that's the proof of the power rule. Yes, there were some factoring things in there you might not have known. You've probably never seen anything quite like this. This is the next level up of math. You will not have to repeat this, but understanding it will help your understanding of what's actually going on in series and a few other topics that may show up on your exam.